I just like to read from this screen right here for a second because I've been, I do computer programming and all that. I look like one, don't I? Anyway, this is the thing. The new quantum computers, you got you got D-Wave, you got, you know what I'm saying? You got a whole bunch of different companies. IBM, they came out with their own quantum computers, which tap into parallel universes, supposedly, right? So that comes down in the Mandela effect, because, that's maybe why things are blending. But here, how to program a quantum computer. Quantum computers are a weird new kind of computer. They burn through unthinkable numbers of parallel universes to run programs faster and use the principles that confounded even Einstein, right? They are the magical miracle boxes that will leave your stupid boxes of transistors in the dust. That's what popular articles will probably tell you. Anyway, they are doubtless, succeed in making this new technology sound exciting, but they can also make quantum computing seem like an arcane art, entrusted to only the cleverest of scientists, certainly not something for the wider programming public to concern themselves with. Nah. Then we start getting out. I don't think this is true at all. And with companies like IBM and Google actually making quantum devices, the time to start playing with quantum computer programming is now. You don't need to do anything fancy at the beginning. You can start your journey into quantum programming at the same place as many of us start our journey into normal programming by making games. Don't worry, having your own quantum computer will not be required. Simple quantum programs can easily be simulated on a normal computer. We can also borrow some time on a real quantum device thanks to IBM's quantum experience, right? And we're going to get into that later. This is the first in a series of articles in which I describe some simple programs made using IBM's quantum API, right? Each will be self-contained version of battleships with simple quantum processes used to implement the basic game mechanics. These are among the first games made for the quantum computer. I'll show you the gory details of the code behind the game so that hopefully you can start experimenting with quantum programming too. Now it goes into what a quantum computer is, so I'm not even going to do that. As well as 1 and 0, this image also flags a couple of important superposition states. And superposition is where you can be in between a 1 and a 0. See, because quantum computers, actually, the actual first computers were analog computers, not digital. And digital being that you got a 1 and a 0, like you got different states. So if I will do a 1, 0, 0, 0, right? So that's 1. So what it is the place value, as we learned in elementary. You count up to 9. You add 1 more to 9. That 1 becomes a 0. That 9 becomes a 0, and you move the 1 over. But that's decimal. So what you do is, that's instead all our computers like this one are based off of a binary, and the binary is you get the first thing you can only go up to 1, and then when you add a 1 to that 1, that becomes a 0, and the 1 moves over, and it looks like 10, but it's actually 2. You see what I'm saying? So anyway, I'm about to, I've been learning how to program these quantum computers because of the Mandela effect. And, they're saying that the actual stuff bleeds over from when you use these quantum computers, you reach out into the other verses, and the other verses bleed over to this one. So that's what I'm working on. All right, y'all. Peace.